All right, so this worksheet you're doing today and the IXL left for the week is exponential growth and decay word problems. So without a calculator, you're not going to be able to do it. I have a calculator pulled up here so I can show you what buttons to press. But the best thing you can do is get yourself the calculator that you could use during the test, which is this one, TI-30XA from Texas Instruments. It has a green button on it, and it's a standard calculator that is allowed to use that you're allowed to use on the EOC. So this here you've seen before. A is the initial value. The initial value is always the starting point, and starting point is the y-intercept. So that first number is always the starting point or the initial value, no matter what number it is. Sometimes that number is 1, sometimes that number is 2 million. It depends on what the number's starting at. Here, the blue variable is B. B is considered the growth factor. Now, it's important to remember how you get the growth factor. You get it by doing 1 plus R if you read in the word problem that it's about a growth. And if you read in the word problem that it's declining, then it's a decay. You would do 1 minus R in order to get what's in that parentheses for B. So on the next page, I have two examples so we can review it. We already did it, so you'll see that it's not new. Now, R, 1 plus R, when I say R is a rate. A rate is a percent. So whatever percent it says in the word problem, that's going to be R. So 15% growth, you're going to put 1 plus 0.15. 15% decay, you're going to put 1 minus 0.15. Either way, the result that comes after is what you call B, the growth factor. Next is time. Very important you remember this detail about time that I'm about to tell you. Write this down somewhere because it's super important. If you see time twice, divide the time. Divide the time. Yeah, of course. So if you see time twice, divide the time. So if I tell you every 3 minutes I fart, how many times will I fart in 120 minutes? You read the word minutes twice, 3 and 120. Which one is your exponent? When you divide it, it gives you 40. 40 is your exponent. So understand that. If you see time twice, divide the time. You with me? Because on your IXL, you're going to have days and days in the same word problem. If you see days twice, divide them. And whatever the answer is, that is your exponent. Clear? Before I move over to the next page? All right, here are two examples. The first example in red is an example of a growth. How do I know it's a growth? Because in here, it's more than 1. The growth factor is bigger than 1. If you multiply something by a factor bigger than 1, it gets bigger. As opposed to the yellow down here, 0.85 is smaller than 1. If I multiply any number times 0.85, that number is going to get smaller. So here's the example for growth. 1.25 is the growth factor. How do you get 1.25? By doing 1 plus 0.25. That 0.25 is your percent. So when it's bigger than 1, you're looking at your percent in decimal form. Now on the yellow question here, same thing. It's 0.85, which is less than 1. So we know there's a minus in there that created that growth factor. 1 minus 0.15 is 0.85. So it's 15% decay. So numbers smaller than 1, just figure out what the difference is for this to be 100. Clear? So now we're going to get to examples of your work today. Yes? Student? All right, so here's two examples. Example number 1, I'll set up in red. Example number 2, I'll set up in a different color after. So you don't have to do this by yourself. We're going to do this together. So first of all, we always start off with y equals a times b to the x power. That's our standard. That's where we start from. Now we just got to fill in the information according to the word problem we're reading. So, a town with a population of 5,000. I stop right there because it says the population is 5,000, which is your starting point. You still having trouble getting in? What? If it doesn't work, just try another computer because some of them are a little glitchy. All right, so a town has a population of 5,000. So A is 5,000. It grows 3% each year. Grows, so I know it's going to be 1 plus a decimal in there. The decimal is your percent. So 3% as a decimal is 0.03. And now, exponent is time. Here it says 10 years. So the exponent is 10. Combine your like terms in your parentheses. And now you have what you're supposed to plug in the calculator. So very important that you do the order correctly. So exponent first. You're going to put 1.03 first in the calculator. Then raise it to the 10 exponent. Press equals, and then you multiply by 5,000 at the end. So I'm going to show you on this calculator the order. 1.03. That's where you start. Exponent 10 equals. We get a crazy decimal. That's okay. We multiply it by 5,000. Now we get 6,719. But it's going to tell you round to the nearest whole number. So because that first decimal is a 5, that 19 is going to turn into a 20. So the answer is 6,720 people. That's how the population would be in 10 years. How about 12 years? You do the same thing, but you plug in 12 here. You with me? None of this is in your brain math work. All of it is in the calculator math work. You just have to do it in the correct order. All right, so let's try example number 2 now. For example number 2, it says Amy makes an initial investment of $5,000. So again, the starting point is $5,000. Now, is this a growth or a decay? Anybody at home can answer also. Is it a growth or a decay? What word tells you it's a decay? You're correct. Now, what word tells you it's a decay? Loses. Very good. So it's not always going to be clear like that. It's going to tell you a word, how much is left, things like that. That tells you it's a decay, so you got to pay attention to the words. Now, since it's a decay, it's going to be 1 minus the percentage, and the percentage is 13.5. To change a decimal to a percent, you have to move the decimal twice. So that's going to be 0.135. And then the exponent is 8 because they want to know how much is going to be the amount after 8 years. So now let's set it up. 1 minus 0.135 is how much? 0.865. Right? Bring down your 5,000, your 8 exponent. Now this is what you're going to plug into the calculator. So 0.865 exponent 8 equals. We get a crazy decimal, it's okay. We press times your initial value of 5,000. 1,567. Any questions on that? What? It depends. If it says round to the nearest whole number, then I rounded correctly because the first decimal is 0.1. 1 doesn't move anything up, it stays the same. That's why I kept only the whole number portion. If it would have said round to the nearest tenth, you would have left the 0.1 in there. And it tells you on every problem what they want you to round to. Now, these first two questions that I just reviewed with you are the first two from your worksheet. Your worksheet has 9 questions. 2 of them are already done because you have the work for them. Now, I want to do 2 from iExcel so you can see that it's the exact same thing. Did it work? I'll log you in and go get you. I'll log in and go get you. Give me a couple minutes. I'll log in and tell you when it's ready. All right, so now on the next page, let's do 2 examples from iExcel. Oh, let's do it right here. All right, so a pot of soup currently 35 degrees above room temperature is left out to cool. If that temperature difference decreases 5% a minute, then what will be the difference in 9 minutes? So first of all, is this a growth or a decay? It's a decay. What tells you? It's left out to cool. When something cools, the temperature drops. So we know this is going to be 1 minus R in the parentheses. So starting point here is 35 degrees. It's going to be 1 minus the percentage because it's a decay. The percentage is 0.05. And the exponent is 9 because 9 minutes is time. Now 1 minus 0.05 is 0.95. Now you're ready to plug it into the calculator. So in the calculator, you're going to put 0.95 exponent 9 equals. You get a crazy decimal, it's okay. Press times 35, which is your initial value, 22. Simple? Now, round to the nearest tenth. So if you put 22, you're wrong. You have to put, this is a decimal you have. Nearest tenth would mean stop after 1 decimal place. To the right of my line, that number's a 5. So that 0 can't stay as a 0. It has to go up to a 1. So 22.1. You with me? Now let's do one more example. Now this here is key. Before I show you this example, let's go back to the notes page. So growth is 1 plus R. Decay is 1 minus R. But there are special cases, so make sure you write this down. The special cases are if you don't see a percent anywhere. So let's say you read a word problem and you have no percent anywhere. Then how do we know what R is without a percent? I'll tell you how you know what R is. If you don't see a percent, you're going to see one of these words that I'm going to put here in this category. Doubles, triples, and half-life. Doubles, triples, and half-life. So this is what you're going to do. If you ever see doubles, triples, or half-life, you're not doing 1 plus anything, you're not going to do 1 minus anything. Okay? If you see the word doubles, you're going to put a 2 in there. Now, think about this. Before I write the rest of them, think about this. If I have $100 and it doubles, how much do I have? 200. Now, let's talk about that. In here, if I do put a R, it would have been 1 plus what to get 2? 1 plus 1 equals 2, right? This represents 100% of your starting point, so your $100. So if this is $100 and this is $100, you have 200, double your money. That's why there's a 2 in there. You with me? So if you see triples in there, what are you going to put? 3. If you see half-life in there, what are you going to put? A half. I'm going to put 0.5. It's easier to put in the calculator. Simple? So now look at our word problem on IXL. What is the starting point of the bacteria colony? 100,000. It says it there. A colony of 100,000 bacteria doubles in size. If it says doubles, what are you putting in the parentheses? A 2. Every 40 hours. Now, usually, if that was the end of the word problem, 40 is my exponent. But what did I say about time? If you see time twice, what do you do with the time? You divide it. So you have 80 hours and 40 hours. 80 divided by 40 equals 2. That's your exponent. Now we can solve this. For this one, I don't need a calculator. 2 to the second power is 4. And 4 times 100,000? 400,000. You with me? This is all you're doing in this whole lesson. And from my experiences, these are the questions students skip every year because they look hard. You see a big old word problem and you see 100,000 and the word bacteria in there. You're telling me that's not one you consider skipping? Now you know, don't skip this question. This is one that you can do in a couple seconds. It's that simple, right? Starting point, growth factor, exponent is time. That's all. Any questions at home? All right, let me show you the worksheet. You can get started on the worksheet once you see it on Google Classroom. I'll tell you when to refresh. 1 through 9 is your worksheet. 1 and 2 we did already, so you can copy the work you have over here. And at the end, there's a couple questions, so make sure you read it correctly. Let's take a look at number 8, at one of the questions they have here. What was the population in 1915? How do you know what the exponent is on that question? Simple. The starting point was 1890. How many years from 1890 to 1915? 25 years. So what's your exponent on that question? 25. You with me? So if they don't tell you the amount of years, you got to subtract the starting point with the year they're talking about to find out what your exponent is. Clear? All right, if you're here in person, I'm going to print a copy for you. If you're at home, I'll tell you when to refresh.